Hi there, Rio Grande third graders. This is Mrs. Jaramillo, and I want to take a look at your assignment in your Envisions math book on lesson 4.2, which is using arrays in multiplication. So we're going to open up our book to our lesson 4-2 on arrays and multiplication. So if you remember, we started this lesson yesterday, and you were going to write multiplication sentences for the arrays that are in this particular book. So if we go to number 6, it says, Mia puts 4 rows with 7 cookies in each row on a platter. A platter is just a large plate. Draw an array to find the total number of cookies. So again, we're using multiple groups, and in this case, an array, if you read up here, it says an array shows objects in equal rows, which a row can be considered a group since we're putting objects into a special group called a row. So for number 6, we're going to, remember we started this yesterday, so we are going to continue. And so number 6 says Mia put 4 rows. So we have 1, 2, 3, 4 lines that we're going to use because a row goes from side to side. And we are saying that each row is going to have 7 cookies. So 7 cookies could be 5 and 2, 3 and 4, 1 and 6. Depends on how you want to place those cookies and think about it. But make sure you're putting 7. So that's 7 cookies in the second row. Seven cookies in the third row, and notice how I'm keeping them even here, so that way I make sure that I'm always putting 7 and 7 in the fourth row. So now that I have 7 cookies in each of my 4 rows, it asks me to find my total number of cookies, which means we don't want to sit here and have to count each one of these. That wouldn't necessarily be efficient. So we could, and when we start learning multiplication facts more fluently, then we will be a little more efficient with knowing how to use addition. So we could say with an addition sentence, 7 plus 7 plus 7. And that's what I wanted you to do yesterday in your instructions. I mentioned I wanted you to write an addition sentence. So 7 plus 7 would give me 14. And this 7 plus 7 would also give me 14. So if I write my total, 10 and 10 is 20. So I put the 2 in the tens place, and 4 plus 4 is 8. So I have 28 cookies, which if I write this as a multiplication sentence, I have 4 rows with 7 cookies in each row, which will give me 28 cookies. Okay. Looking at number 7, and again, I'm not going to go over every single one of these, but I do want you to be checking these as we go. So it says write a multiplication sentence for each array. Well, first I'm going to write an addition sentence. So I'm looking at my rows, and I have these groups, and I have 1, 2, 3, 4, 5, 6. There's 3 here and 3 here. So the first row has 6, my second row has 6, and my third row has 6. So you're checking this on your paper. Remember, you're not writing in your book. I will go back and erase this. But if you notice, I can also write a multiplication sentence because I have equal groups. So I have 3 rows, those are my groups, and in each row I have 6 counters in each group or each row. So when I add 6 plus 6, that gives me 12, plus another group of 6 will give me 18. So when I use my multiplication sentence, that would also provide me with 18. Now, of course, I could count each one of these individually, but again, that is not an efficient way to help you with becoming more fluent with your adding and your multiplication. So we want to get away from having to do that. Our next problem, we have 1, 2, 3, 4 rows, and 1, 2, 3, 4 in each row. So we know that there's 4 here, 4 here, 4 in that row, and 4 in that row. So if I write an addition sentence, it would be 4 plus 4 plus 4 plus 4. And if I write that equivalent to a multiplication sentence, it would be 4 rows with 4 in each of my rows. So 4 rows with 4 in each row. Now, with number 9, it's a little more difficult to write an addition sentence because there's only 1 row here. So I have 1 row with 1, 2, 3, 4, 5, 6, 7 in that row. And the total number of counters that I have is 7. So anytime you have 1 row of a certain number, it's going to be 7. Or it's going to be whatever that number is that is in your group or in your row. One way to also think about this is you're adding 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Okay, so now let's take a look at number 11. And I'm just going to write my number sentence over here for number 11. And my equation or my number sentence is 5 times 6. So I have 5 rows and I will have 6 in each row. And I want to know how many total objects will I have once I have 5 rows with 6 in each row. So if I draw an array, remember I'm going to use 1, 2, 3, 4, 5 lines because the lines are considered the row here. And I'm going to place 6 in this row. And I'm looking at that as 3 and 3. 6 in this row. 6 in a third row. 6 in my fourth row. And 6 in my fifth row. Now remember, you're also writing an addition sentence for this. So I could add 6 once, 6 twice. I have 6 objects in that row. I have 6 objects in that row, and I have 6 objects in that row. So if I use my understanding of my doubles, I could add 6 plus 6 is 12. And this group of 6 plus 6 would also be 12. And if you know what 12 plus 12 is, 10 and 10 makes 20. And 2 and 2 makes 4. So that means that I would have 24 with these 4 groups of 6. And then I need to add 6 more for this group of 6 here. And 6 and 4 makes a new group of 10. So it's very important for you to remember your 10, how to make a 10. So we'd have 6 and 4, or 7 and 3, or 5 plus 5, 8 and 2, 9 and 1. But those are some really important facts to remember in your addition, especially since when we do make a new 10, we regroup that 10 to make a new 10 here in the tens place. So when I add 6 and 4, that makes 10, and now I add that 10 to the 20 to make 30. So that's 6 and 4 makes a new 10, and that 6 and 4 is now going to create a new 10 added here to my tens place. So we know that when we multiply 5 times 6, we get 30. Okay, so let's take a look at number 14. We have the multiplication equation of two groups of 9, or 2 times 9. So I have two groups of 9. I'm drawing an array. So 4 and then 5 more is going to make my 9. So I'm going to put 9 in the first row, which I did, and 9 in my second row. And my addition sentence would be, I have a group of 9 here. If I were to count those, I shouldn't have to because I already know that there are 9. And I add another group of 9 here. And when I add those two groups of 9 together, I know that I'm going to get an even number because I have partner pairs, which means I have an even number of 9 and 9, making my 18. So when I look at my product here for two groups of, or two rows of 9, I have 18 total counters or objects in that row. Okay, so now if we take a look at 15, 16, and 17, we are using a greater than, a less than, or an equal symbol for each comparison here. So you will notice that we are comparing 3 times 6 to 3 times 7. So if I were to write an addition sentence for number 15, and I'm using my understanding of addition to help me compare these, if I have 3 groups of 6 here, but I have 3 groups of 7 here, we're using our addition to say, oh, I know I have 6 plus 6 plus 6. Here I have 7 plus 7 plus 7. I have the same number of groups, it's just here I've got one more in each one of these groups than I do here. So 7 is a larger number by 1 than groups of 6. So we should already know that if I have 3 groups of 6 and 3 groups of 7, 3 groups of 7 is going to be greater. So we could say 3 times 6 is less than, and we read it like a book going from left to right, is less than 3 groups of 7, or 3 times 7. So that's number 15. Number 16, we are comparing 2 rows of 4 to 4 rows of 2. So if we use our understanding of addition again, and skip a line here, I have 2 groups or 2 rows of 4, and I have 4 rows of 2, then I know I have a 4 in the first group and 4 in the second group. With this multiplication sentence, I have 2 and another group of 2 and another group of 2 and another group of 2. Now I have 4 rows or groups of 2. So if you think about these 2 groups of 2 would make that 4, And these two groups of 2 would make this 4. So when I add 4 plus 4, 4 plus 4 is 8. When I add 2 plus 2, which is 4, and 2 plus 2, which is 4, again, we know that that's going to be 8. So these are going to be equivalent or equal to one another. And when we get to our lesson on the commutative property or the order property, we'll be looking a little more closely at how this property works in our next lesson. 17 has 5 groups of 6 or 4 groups of 6. Well, think about how many groups of 6 are we really comparing? We're adding the same number over and over again, except we just have more groups here than we do here. We have one more group of 6 to add than we do here. So this would be 6 plus 6 plus 6 plus 6 plus 6. Whereas with 4 groups of 6, I'd add 6 plus 6 plus 6 plus 6. Here I have one less group of 6 to add. So, knowing that 4 times 6 is really right here, we should know that one more group of 6 is going to make this a greater amount, just by knowing that there's one more group of 6 being added here than here. But we can go ahead and add our groups of 6. And we did this earlier. 12 plus 12 is 24. And then we add one more group of 6. That makes it 10. And so this is 30 on this side. And 6 plus 6 is 12. And this group of 6 plus 6 is 12. And we just did that earlier. So this is going to be 24. So we know that 30 is greater than 24 when we compare the two amounts. Another question I really want to delve deeply into is number 21. Number 21 says, Margot has 23 pictures. Can she use all of the pictures to make an array with exactly 2 equal rows? And then they want you to explain why or why not. So if we were to draw using 2 rows, in this case, 2 rows would be 2 lines. So we could have a row 1 here and a row 2 here. Now, if we think about putting 23 pictures into these 2 rows, and I'm just going to draw circles for the picture. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So you will notice that when we get to 23, we don't have a partner pair here to make exactly the same number in each row. So when we think about Margot's dilemma or problem, we think about how are we going to write this as an answer statement and how are we going to explain this? So let's go back to our array here, and for number 21, we could say Margot cannot or can't put 23 pictures into 2 equal rows because, and so one of the things that we can add to this to explain is our number is not even. And since it's not even, we would be unable to put it into an exact partner pair here. So, because it is an odd number, so that's one reason. We can also state that one row would have 12 and the other row would only have 11. So we can say one row has 12 pictures and row 2 has 11 pictures. Now, something that one of the students mentioned earlier today, we could add a picture to make it even, or we could take away a picture to make it even. But those are just some ideas on how you can explain why or why not Margot can put these pictures into exactly 2 rows or equal rows. So, looking at number 22, we want to choose an answer, or excuse me, an equation that would match this array. So, looking at our array, we have 1, 2, 3, 4, 5 rows. I see 5 here. Well, actually, we see 5 in all of these, right? But which one of these equations is going to help us say 5 rows? Well, again, we have 4 in each row. So when we look at rows and the same number in each row, we know we are dealing with multiplication. So here in our multiplication sentence, we have 5, which tells us our rows, and 4 that tells us how many are going to be in each row. So our best choice for this equation, or for the equation for this array, is going to be 5 rows of 4, 5 times 4. So that's the one, those are the ones that we're going over today. We will be working with lesson 4-3 on Thursday. And let's keep working on those math facts. Have a great afternoon.